we go. Discrete probability distribution. Okay. We've talked about distributions before. We had frequency distributions earlier in the year. And remember, a frequency distribution was just a table that showed like the classes and then how many were in each class, the frequency. Well, a probability distribution just shows like all possible outcomes and then the corresponding probabilities. And then we got to talk about discrete. So, a discrete probability distribution lists all possible outcomes from an experiment and the corresponding probability. Okay. And that's really what a probability distribution is. What makes it a discrete probability distribution is whether the outcome is, well, I'll talk about it right now, discrete versus continuous. Okay. A discrete random variable has a finite, what's finite mean? What? A definite. You can actually count it. Infinite goes on forever, there's no end to it, you can't find the end. Finite is the opposite of that. There is an end, I can count. So it has a finite or countable, you could say countable, number of outcomes. Of possible outcomes. Okay, as opposed to a continuous random variable, has an infinite number of possible outcomes. The way I like to tell the difference between the two is for a discrete, you can only get a whole number for an outcome. Like whole number meaning no decimal. With continuous, you can get in between whole numbers. You can get a, say, 2.6 or a 1.7. So that's how I like to tell the difference. This only has whole numbers. Only whole numbers. This one can have decimals. So I'm going to give you two situations and you're going to tell me if they're discrete or continuous. Okay, I'm going to collect some data on how long it takes you to complete a test. So the data I'm going to collect is the time used to complete a test. kind of units do you think I'd be measuring that in? What would I be recording? Probably minutes. So I'd be collecting how many minutes it takes you to finish the test. And then leave a line here, we'll say which one that is. And the other one, I'm going to look at the number of home runs in the baseball and softball season. I'll just say per season. And look at what's happened. Those are our two situations. Do you think that first one is a discrete situation or a continuous situation? Why continuous? You could have like 35.6 minutes, or you can get in between. It doesn't have to be 35 minutes or 36 minutes. You can get stuff in between. That's how you can tell. So there's an infinite number of possible answers here. So that's what makes this one continuous. Because I can get in between there. How about home runs? Can I get 2.5 home runs per season? No, I either get a home run or I don't. They're all whole number answers. That's what makes this one discrete. Well, it doesn't go down as a home run now, does it? I didn't say I was just counting number of home runs. I'd have like the year and the number of home runs, the year, the number of home runs. Not doing any probability, just recording the number of home runs. The time, it would go down as a home run. It's a home run. 1. Add it to the list. Don't care what kind it is. It's either labeled as a home run or it's not. Okay, are we good on discrete versus continuous? And like I said, the easiest way to think about it is, can this come up in between whole numbers? Could this come up in between whole numbers? And that's what it tells you. Could it? Don't have to have one, but could it be an in-between number? Okay, got that. We are going to be focusing this whole chapter on discrete probability distributions. This first stage is kind of a general thing, and the rest of the chapter gets into some very specific ones. Yes, we're working with whole numbers all year. Okay, so a discrete probability distribution has to have two things that happen. Well, I should have wrote them down up there, but I'll get them here. Discrete. You can do anything you want there, your notes. Distributions have two characteristics, I guess. Each probability has to be between 0 and 1, like a regular probability scale. And the second thing, the sum of the probabilities has to add up to 1. So that means you've got all possible outcomes, so I should have all the probabilities and they should add up to 1. So let's make a probability distribution from a frequency distribution. Make a probability distribution, PD, I like it, from a frequency distribution. You should think this is very easy. Okay, our example we're going to do is, a company tracks the number of sales that new employees make each day during a 100-day probationary period. The results for one new employee are shown at the left. Construct and graph a probability distribution. So this is one person's results for 100 days on the job, so they're looking to see whether they're going to keep this person or not, or maybe they've got to cut someone and look at all the new ones, and they look at this data and decide, okay, you're the weakest salesman, they're gone. So, the sales per day Do you see how that would be discrete, sales per day? The number of sales they make? Can they make 2.5 sales? No, you either make a sale or you don't. Add them up, so it's going to be whole numbers. Yep. Okay, so this person made anywhere from 0 sales in a day all the way to 7. What do you think they're selling? What are they selling? Vacuum. I thought shoes, maybe.
No, you've never had those people come to your house and try to sell vacuums?
Yeah.
They come in all the time, like
Oh,
every week.
every week.
Like, I don't know what type of sales when you're getting at your house.
Yeah. I don't know. 7 vacuums in a day, that's... Okay, 16. 16 days out of 100, they made no sales. 16? Listen to these so you don't have to keep bobbing up and down. You ready? First one's 16, next one is 19, 15, 21, 9, 10, 8, and 2. I thought they were shoes.
Yeah, but a lot of people need shoes, so why would they not sell any shoes?
Well, maybe the weather was bad. Was the store still open?
The weather was bad. Okay.
I don't know.
Maybe they live
Okay, that's what you're given. There's the frequency distribution. I'm asking you to make the probability distribution. So I want to know what's the probability that they make no sales per day. What's the probability that they make 4 sales per day? The probability that they make 7 sales per day. How do I turn this information into a probability? Yeah, because you would add these up. Now they made this one easy enough because I said it was 100 days. So these frequencies here do add up to 100. Is that going to happen every single time? No. So you're going to have to sum up the frequencies. And then how do you turn that into a probability? This is what we did in the last chapter. There it is, Ashley. It's just that hard. What did you want to say there? Divide frequency by the total. So this one's easy. It's 0.16, 0.19, 0.15, 0.21, 0.09, 0.10, 0.08, 0.20. The one in the homework, probably you're going to have to add those up, and it's not going to be 100, and you're actually going to have to divide and get to figure it out. But that's a probability distribution. Oh, thank you. Yeah, they didn't have 20%, yeah. Not a 20% chance they're making that many sales. 0 to, my bad. And if I added all of these probabilities up, what are they going to add up to? 1. I'm going to go for 1, and you would be correct. Okay. We don't need to, they want us to make the histogram for it, but we don't need to make the bar graph. I think you're fine without that. Is this next one a probability distribution? If yes, say Y. If not, say Y. We're looking at the days of rain. Zero days of rain, 1 day of rain, 2 days of rain, and 3 days of rain. I think they were looking